Hello everyone, welcome to a new session about quick facts in controlled environment agriculture. Today we are going to be learning about lighting calculations. So probably this will be a very basic class for some of you, but I know that for a lot of growers we have sometimes doubts in this topic. So let's go over this information. So how we measure light? I know that sometimes when we work in indoor facilities or greenhouses, we have different ways to measure light. We sometimes have sensors that measure in watts per square meter. For example, this is very common in greenhouses when we try to measure radiation. And also in indoor facilities, we have a lot of growers that can work also with luxes. However, it's very important to understand that if you want to get a better understanding of the amount of light that your plants are receiving, you should be working with photosynthetic photon flux. So this is the amount of light that the plant is receiving within the range that the plant utilizes for photosynthesis. So this will be the correct unit to understand the amount of light that the plant is receiving to work on your system. Now, when we measure ppf, we're speaking about just instantaneous measurement of light. However, if you want to know the amount of light that the plant is receiving per day, then we rely on the DLI, which is the daily light integral. This will be the amount of light that the plant is receiving per day, and the unit is moles per square meter per day. So it's very important to understand how to calculate this, because this way you will know if you have too much light or if you don't have enough light inside of your system. So basically, DLI is one of the most important units when trying to understand if you have enough light in your system. So how we measure light, for example, in a facility where the sole source of light is artificial? We always recommend to measure ppf at the canopy level. Here are some examples of sensors that you can use to measure ppf. There are some handheld sensors and also some sensors that can go connected to a software to be able also to calculate DLI. However, if you want to calculate the DLI by yourself, you should be able to measure ppf at the canopy level. We recommend to do some measurements across the system so you can have an average. And for example, for lettuce, we always try to target about 250 or 300 micromoles per square meter per second. This is the unit that we use to measure ppf. So now that you have the exact ppf or the average of ppf that you have on your system, then we can calculate DLI. So how we calculate DLI? Here we have the DLI formula. Actually, this formula can also be used in different ways to calculate, for example, the amount of hours to deliver a specific DLI. So you can play around with this formula. But for right now, let's focus on calculation of DLI. If you want to calculate DLI, you need to know the light intensity using the correct unit, which is ppf in this case, and the hours of light that the plant is receiving, meaning how many hours are you turning your light on. Remember, if you are looking to provide a specific DLI, you can play around with this formula to calculate the hours of light for a specific DLI. So let's run an example where we have 280 micromoles per square meter per second as our average light intensity at the canopy level. Then, as an example, let's use 16 hours of light. This number, of course, can be different. Both numbers can be different depending on your case. So in this case, we have 280 micromoles per square meter per second. Remember to use the correct unit in here. Then we have 16 hours of light, and the total DLI in here is 16.1, which is a DLI that we know is good for lettuce. So how we know this? So DLI is very important, and this is basically because we have enough information about a lot of crops and the DLI requirement. So you can go and check tables like this one where you can get to know the minimum and optimum levels of light for different crops. For example, for lettuce, we have a minimum requirement of 12 and an optimum requirement of 17. So these are the numbers that you need to check when you are working in a facility where the sole source of light is artificial. You will be targeting at least to have the minimum DLI that is required by the plant. Also, if you're working in a greenhouse, for example, you can require supplemental lighting where the natural light is below the recommended levels. So you can also use the formula that we shared in order to calculate the amount of DLI that you need to add into the system to provide the minimum or the optimum DLI for your plants. We can be working with different systems, we can deliver light in different ways, but however, we always have the same objective, to deliver the amount of light that the plants require. So always think about having at least the minimum or the optimum DLI for your crops. I hope you found this information helpful. Please help us sharing this video so more people can get to understand how to calculate light inside growing systems. Remember, my name is Carla Garcia, Horta America's Technical Service. See you on the next video.